All right, welcome everyone. Thank you for joining us today. I'm Chris Wong, Head of Developer Relations here at Mapbox, and this build session is called From Field to Screen, Designing for Real-Time Conservation Impact on Land and Sea. Before we get started, just a few logistical notes. This session and all build sessions are being recorded, and they'll be available to view after the event. We will be inviting live questions for our guests. To participate, please submit questions through the Zoom Q&A feature. You'll find it at the bottom of your screen. If you ask questions in Q&A, it's a little more structured than if you ask them in the chat. So we ask that you do that, and we'll ask our guests may be able to respond to them in writing or may also be able to respond to them live if there's time at the end. Make sure that captions are available for those that need them. They're available in multiple languages, so use the caption button in your Zoom interface. And you can discover all of the build sessions available throughout this week in our Zoom event lobby or at mapbox.com/build. That's it for me from the logistical notes side. So now I'm going to turn it over to our speakers. Daniel O'Neill, who's a lead software engineer at EarthRanger, and Josh Hansen, who is a tech lead, both from the Allen Institute, and are going to tell us some great things about these conservation products that they built. So take it away, gentlemen.
Hi, I'm Josh. I'm a software engineer at the Allen Institute for Artificial Intelligence. Um, and just a real quick primer on what AI2 is. We are a research institute in Seattle, and we're working on building breakthrough AI to solve the world's biggest problems. And today we're going to talk to you about how we use Mapbox products in conservation-focused products at AI2. I work on Skylight and Dan works on EarthRanger, like he mentioned. And these products deliver meaningful impact at a global scale on a daily basis. So to start out, I work on Skylight. And Skylight is a maritime analytics platform that uses AI to support global enforcement and compliance efforts toward reducing illegal, unreported, and unregulated fishing. Our users include protected area managers, analysts, and enforcement agencies, and Skylight is offered at no cost to all of these organizations. You can see here, this is a very simple view of what our system looks like, but basically we collect data from satellites, we ingest it into our data pipeline, and then we make that available to maritime analysts through a web UI. We make heavy use of Elasticsearch, which is great for serving vector tiles, and all of the other data that we collect. And so what product of Mapbox does Skylight use? Primarily, we use Mapbox GL that's in a React.js application. We make use of Studio to generate base maps to add context for users. And we make extensive use of vector tiles. Vector tiles are the greatest thing ever. And I'm going to say that over and over again because we love them. So here's just an example of the types of base layers that we are currently using. We have a bathymetry layer, which is showing ocean depth. And some of the interesting stuff that you can see here is that ocean depth is very important for fishing. You can see there's kind of a ledge here in this diagram, and all of the fish icons are right along that ledge. Other things that we have are exclusive economic zones and territorial waters, and then also we allow users to define areas of interest that they want to do any special reporting on. One of the big things that our users use is using the maps to visualize where vessels have been. And you can see that in this screenshot or this animation here, where we're color coding the vessel tracks based on things like speed, their identifier, their activity, and the time of day. And that allows the analysts to know exactly what's going on at a glance without looking through all of the data. Another thing that we do and use Mapbox for is we show vessel movement over time. This is a 30-day window and sliding through it about a day at a time. And you can actually see where all of the fishing vessels are moving and what they're doing. You can see all the flags on those vessels. So you can see a lot of Chinese and Spanish vessels, some Japanese vessels. And this is also very important to our users who are monitoring these areas and have things like licenses that they're monitoring for who's allowed to be fishing in their waters. Uh, Going back to showing the vessel tracks, you can see here that these are all of the vessels that crossed uh, the Horn of Africa over a 24-hour period of time. And it looks like a big jumble mess. But if you can isolate the activity types, you can actually see the fishing behavior very clearly. And I'll say it again, we really love vector tiles because it makes all of this super, super easy to do. Um, it's great. Another thing that we do is show where vessels are using satellite imagery. And we use AI models to detect vessels in satellite imagery. We're collecting it from all sorts of open and freely available data sources from NASA, ESA, NOAA. And we really strive for near real-time data access for these things. And so once the images are downlinked from the satellite, which we don't control, we usually have them in the platform within minutes for our users to see where the vessels are in their areas. Another cool feature that we have is leveraging commercial satellite data providers. And you can see that the commercial providers are available to show much higher resolution. You can see the screenshot here. And the way we use this is it's expensive. It costs a lot of money to do this. And so we have a system where based on very particular events, that might be interesting to our users, we are sending a request to the satellite provider to actually go move a satellite into position and take a picture of that area as quickly as possible. And this is really important for collecting potential evidence for potentially illegal activity when it happens. Um, and that's what I've got for Skylight. I'll hand it over to Dan.
Thanks, Josh. You want to run the slides, and then if I demo, I'll take over.
Yeah, I can do that.
Yeah, great. Thank you. Yeah, I'm Dan O'Neill. I'm one of the tech leads on the EarthRanger team for the mobile app as part of our platform. And EarthRanger is a protected area management software platform that brings in a lot of different resources to protect wildlife. And it's really value added. It's all in real-time data. Okay, next slide. And so a lot of what we do on the web is very similar to Skylight technology-wise. So one thing we do on the EarthRanger platform that's a little different is we collect data through a mobile app, and we do some analysis on a mobile app. And how we use Mapbox is with React Native. And if you're not quite familiar with React Native and how it leverages the native Mapbox SDKs, essentially you're building a React style app that can compile itself down to the native objects and then uses a JavaScript bridge to communicate between the native SDKs and the JavaScript code that you write. So it's pretty straightforward, and you basically build a map view component, and you can have child stuff involved with that, and then you basically build data sources and layers, right? And we're going to focus today. We don't have a lot of time, but I wanted to focus today on how we do some custom symbology in the app. But essentially, you get a GeoJSON data, gets the native Mapbox, and then it gets rendered on the GPU. Features we do are switch base maps, view layers, navigate to data layers, zoom to layers extent, and then we do this custom dynamic symbology, which is what I'll talk a little bit more about. But go ahead, next slide. So data collection, you can go to the next one. It might be animated. Yeah, keep going. So one of the ways we collect data is in three ways, right? And one of it is real-time tracking. So we have all these different sensor data, all these different feature type data that goes into the EarthRanger platform. And the mobile device itself, as users use it, become a asset into the system. And so this is showing you that as when you have an internet connection, as you're moving and tracking with the device, you get to see it real time over the web, over the command center. Go ahead, next slide. And patrols is another type of data collection we do, and that's really sort of a configuration on top of tracking. So whenever you're patrolling, you're tracking, but you're adding context to what you're doing. You're doing some sort of task-oriented thing for the day, or multi-day, multi-week. So there's more information, as you can see on the thing there, and take notice of the symbology that you see there. We'll talk a little bit more about that. And then while on patrol, if you want to hit the next slide, you can collect events. And here we use Mapbox locations and polygons to distinguish between two types of events. And when you create an event, you essentially have either an area that you want to do, a fire boundary, something like that, or a location, a point in space. And then you get form data that's attached to that, so you can collect information about the event that you're doing there. And then you can add attachments like notes to send back to the base, and or images for those events. Go ahead, next slide. And so now that's data collection, and all of that data gets into EarthRanger. And the way the mobile app philosophically works is when you have an internet connection, it is trying to upload as fast as possible, right? So if you're tracking, we're being really aggressive about getting those data points up, so that to keep the real-time nature of the platform. When you're creating an event or a patrol, the start time, the event itself is getting uploaded as soon as possible. The app works completely offline, so if you are offline, all that data is persisted in a SQLite database with the philosophy of when we get an internet connection, we're polling for that. We want to upload as soon as possible. So again, for that real time. So now we're down to, we want to do some potential analysis. All data gets onto EarthRanger in many different forms. And so analytic data will come from us from other things. So again, take note of the symbols here. We call these things, these assets, sort of subjects. And a subject is something that is trackable in the EarthRanger system. Here you're seeing wildlife, but it could be obviously mobile devices. It could be a wide range of things that we'll see on a next slide. Go ahead. So here's a slide that sort of demonstrates that with EarthRanger as the centerpiece. Data that can come in can obviously be the mobile app, it could be radios, it could be satellites, it could be Skylight data from that platform, it could be fishing, boating data, iNaturalist, camera traps, weather sensor data, all kinds of different data can come into the system. And parts of that can come in through events or subjects. And so not data that we collect, the app actually can consume that. And then we can do analysis like, I need to go find a subject, maybe an elephant, do some sort of event on that, or I'm going to go to an event of some sort and do some follow-up with that event. Okay, next slide. So here so in a lot of those screenshots you saw different icons. So a challenge we have from a development perspective is we have over 800 sites, and we have a lot of different representations of these sensor data, all this data that's coming in. And it can be site specific. It could be, some of them are generic, but a lot of them are, the bottom line is they're very dynamic. We don't have a standard set. So a challenge we had was, how do we represent that offline and online in the way we do our symbolization? And so the way we do symbols is essentially we have a leader component with a background, and then inside of that, it's embedded is the icon representation of whatever asset it is, whatever subject it is. These can be wildlife, helicopters, radios, all those things I mentioned before. And so the trick we did here was, so we persist the SVG at the database level, and we create a couple of placeholders, and then that wrap the process of what the full symbol is going to be, and then dynamically in the icon image, we basically take that placeholder and pass it in an SVG that comes out if it has one. If it doesn't, then it falls back to a default symbol. And then essentially it gets used in there. So the workflow is very much this dynamic image registration process, right? Where we have two of those because for selected state versus unselected state, wrap that into the symbol set, essentially all of the styles that go into that, and then register that with Mapbox, and then attach that to the GeoJSON data, and then you get what you see on the device. So I'll go ahead and demonstrate a little bit of that on the mobile device for you, just to get a sense of what that looks like. Okay, so you're seeing a large port. I had a little bit of trouble just isolating the mobile app. So you're seeing on the left-hand side the container that hosts these, but hopefully you're seeing on the right-hand side the mobile app itself. Let me know if you don't. So first thing I want to show is the really high performance here. We're definitely using this at zoom levels, right? So to minimize this isn't a lot, but we can have sites that have over 1,000 to 1,500 icons, all dynamically generating these icons on the fly. And so you'll see some of the different ones here, and notice some of the symbology here. The blue background are the subjects, which can be any types of assets. Here we have examples of weather stations, animals, radios, that sort of thing. And then the colored ones, green, red, those are the status levels of an event. So if you open up an event, you'll see some event data associated with that, right? And then you can go to that event. If you look at a subject here, this is an elephant, and you get some data on that. You see the symbology. You can see each point. These are all the sensor data. All those arrows represent the sensor data that's coming in. So you can imagine how many on a large site is going to get, on order of millions of these sensor data. And then on the platform itself, we do real-time tracking. Here we basically have when the last known location is, and that's sort of shown on the bottom here 53 minutes ago. We have a sync mechanism here manually to go get updates on our analytic data. Data that we upload is automatically uploaded. Data that we analyze with, we sync. So now you see, whoa, the Horton now we have 1 minute ago is no longer there, right? So Horton's now over here, and if we update that, we'll see all the tracks between the last time I was updated. So this gives you information on how long ago that this particular animal or this asset or the subject was there. If I'm going to go to it, I can go into a go-to mode. This gives me bearing on distance, and I can attempt to approach that subject and asset. Yep. And so that's our custom symbology. That was, like I said, that was an innovative way of sort of allowing us to get some of these unknown icons mapped at scale. Again, there could be thousands of them. And yeah, that's all I have. If you want to go back to the slides.
So thank you, everybody. If you want more information about Ai2 or Skylight or EarthRanger, here are the addresses. And Chris, I think we do have some time for questions if folks want to ask them.
Sure. So there's one specifically about follow-up. So I see some URLs here, but I guess somebody's asking if they wanted to follow up with you guys. Is there a better way, or is there like a contact form somewhere they could fill out?
I can shoot a private message directly if that works.
Okay.
With email addresses.
Sure.
Yeah, absolutely.
And I think you started answering this question in the Q&A, but I think you have the quote of the week: "Vector tiles are the greatest thing ever." We're gonna put that one all over social media. Yeah, can you say more about what makes them better for your use case and how
Yeah.
why they're better?
So the real power that we see is actually when we pair it with Elasticsearch. Elasticsearch has a built-in MVT Mapbox vector tile endpoint that allows you to basically hand it an Elasticsearch query, and it will just give you back Mapbox vector tiles. And so you can basically just point the Mapbox layer at it, and with all of your query parameters, you work that into React with all of your filters being dynamic, and work in all the expressions that you need to kind of react, sorry, no pun intended, to kind of the changes in behavior. And it's like magic. All of the styling just happens almost instantly. And so we've gone from trying to, render our own layers of like JSON into line strings and polygons to just relying on the vector tile capabilities to do all of the stuff that we would have either had to do our own implementations, or even worse, like raster tiles, where we're running our own tile servers to do that in real time.
Awesome. So when those come out of Elasticsearch, are you cutting them as static vector tiles and hosting them somewhere, or is that more like a real-time thing?
It's mostly just real time. These are usually in response to user specific queries for very specific things that they want. So it's all on demand in real time.
Awesome. Thank you. Okay, so one more question came in specifically for when using EarthRanger. How do teams navigate in the field for the most part? I'm sure it's a mixed bag, but are they usually like on tracks and roads, or do they need bearing and direction because they're kind of off-roading and there's nothing, they're not driving down a street or road or path?
Yeah, absolutely. There's very few paths. It depends on location, but we have plenty of mobile users who are on air and plane, or fixed wing. We have on foot. We have also vehicles. So vehicles 2 foot, but yeah, rarely is the subject that you are navigating to on a path.
I see.
So generally, if you're not in the air or doing some sort of survey, air is good. We do a lot of air surveys. If you're not doing something like that and you're on foot, you're generally going to leave whatever asset or vehicle got you there and peruse on foot.
Awesome. Okay, well, I think we're at time, so that'll wrap us up. So really appreciate Josh and Dan sharing these two amazing projects with us. So they left URLs for you to check out more info, and thank you for contributing to build and making this awesome session. So we'll see you all at the next one. Take care.
Thank you, guys.